Welcome to AI Podcast. I'm Alex, and today we're unpacking an OpenAI paper titled Let's Verify Step by Step. It's about teaching models not just to get the right answer, but to reason correctly along the way.
I'm Maya. That sounds like something we all want from AI. Less guessing and more careful thinking. What's the quick takeaway?
Here's the short version. When you train a verifier to judge each intermediate step in a model's reasoning, rather than only the final answer, you get more reliable decisions about which solutions to trust. On tough math problems, this step-by-step approach outperforms final answer scoring and simple majority voting, and it also makes data collection more efficient.
So the message is, supervise the process, not just the outcome. Who led this work?
Representative authors are Lightman, Vineet Kosaraju, and Yura Burda at OpenAI, working with colleagues there.
Right. Before we go deeper, set the stage. What problem were they trying to solve?
Language models can produce long, persuasive explanations, but they still make subtle logical mistakes. Traditional reward models score only the final answer, which we call outcome supervision. The issue is credit assignment. If the final answer is wrong, it's unclear which step failed. If it's right for the wrong reasons, the model can learn to prefer shaky reasoning.
Yeah, I've seen those convincing but flawed write-ups. What did people try before, and why wasn't it enough?
Sampling many solutions and using majority voting helps, but it treats the chain of thought as a black box. Earlier comparisons of process versus outcome supervision were small and focused on easier datasets, so they didn't settle what happens on harder problems at larger scale.
So what did this paper do differently?
They trained a process reward model, a PRM, that scores each step of a solution. Human raters mark steps as correct, incorrect, or neutral, and they stop labeling at the first mistake. That keeps cost manageable while pinpointing where reasoning breaks. At selection time, the verifier aggregates step scores and picks the best solution from a batch.
That stop at the first mistake rule feels practical, like a teacher saying, "Here's where you lost the thread."
Exactly. And they scaled it. They released PRM 800K, a public dataset with roughly 800,000 step-level labels for math solutions.
How did they test whether this actually works?
Two ways. First, a large-scale setting on competition-style math problems using best-of-n search. The model generates many candidate solutions, and the verifier chooses among them. They compared three selectors: the process-supervised verifier, an outcome-supervised verifier, and majority voting. Second, smaller controlled studies held data sources constant to compare process and outcome supervision directly.
And the results?
On the hardest math problems, as you search over more candidates, the process-supervised verifier pulls ahead. Think around the high 70s for accuracy in very large best-of settings, versus the low 70s for outcome supervision and a bit lower for majority voting. The gap widens with more search, suggesting the process verifier is better at spotting genuinely sound reasoning.
That tracks. If you're sifting through lots of candidates, you want a critic that understands the logic, not just the final number.
They also looked at data efficiency. With an active learning strategy that selects convincing wrong answers for labeling, meaning solutions that look good but end incorrectly, they report roughly a 2.5 times improvement in label efficiency.
Nice. Did they check generalization beyond that main dataset?
Yes. On recent AP and AMC style exams, the same pattern holds. The process-supervised verifier outperforms outcome supervision and majority voting there as well.
What's happening under the hood during selection?
Imagine a solution broken into lines. The verifier predicts how likely each step is correct, and then combines those predictions into a single score. If early steps are shaky, the overall score drops, even if a later step tries to patch things up.
Give me a quick example.
Say an algebraic expansion is wrong near the start, but the answer happens to match by luck. Outcome-only scoring can be misled by the final answer. Process supervision penalizes the solution right where the mistake appears, so a cleaner solution rises to the top.
All right, let's put on the skeptic hat. What should listeners be cautious about?
First, evaluation. Because some collected labels touch the test set, the authors report results on a clean subset. That's careful, but it narrows the official test pool, so representativeness matters. Second, reproducibility. The data set is public, but the strongest numbers rely on powerful internal models and tooling, which can be hard to match. Third, labeling choices. Stopping at the first mistake and allowing neutral steps are sensible, but different protocols might shift outcomes. Fourth, some controlled studies use a large process model as a labeling oracle, which risks baking in its biases. And finally, the headline metric emphasizes best-of-N search. Many teams will also care about one-shot performance and integration with training.
Active learning can also be tricky. If the selector changes while you collect data, things can get unstable.
Right. They observe some instability when retraining the selector during data collection. That's an area for improvement.
So why does this matter beyond math?
Many real tasks need trustworthy multi-step reasoning, like coding, scientific question answering, and tool use. A process-aware verifier can flag where reasoning stays on track and where it veers off, which is also helpful for safety and alignment.
If someone wants to try this in practice, what's the minimum to get started?
A generator that writes clean, line-by-line solutions, a way to collect step-level labels on at least part of your data, and a simple process reward model to score and aggregate steps. Even at small scale, the paper suggests advantages over final answer scoring.
Wrap it up for us.
Supervising the path, not just the destination, makes verifiers more reliable. On challenging math problems, process supervision selects better solutions and uses labels more efficiently, and the dataset they released makes it easier for others to build on this.
This has been AI Podcast. I'm Maya with Alex. Thanks for listening.